Cliff diving in Hawaii. This recording took place in Black Rock, Maui, Hawaii. The students involved in the video are Saul Diaz, Ashley Davis, and Ariana Fayard. The physics of cliff diving. When observing the physics behind cliff diving, there's information that can be collected, which is velocity and the force upon landing in the water, and the height of the cliff that is being jumped off of. There are some factors to be taken into consideration that play into cliff diving, like air resistance, the weight, and the technique that is used to jump off of the cliff. They aren't taken into consideration because this is a free fall. The following equations were used to obtain data from each person's dive. To solve for force, upon hitting the water, mass and acceleration due to gravity are multiplied together. To solve for velocity upon hitting the water, total time and acceleration due to gravity are multiplied together. To solve for the height of the cliff, initial velocity is multiplied by time and added to 1/2 the acceleration times time squared.
So for Saul's jump, to find the force, you use Saul's mass times acceleration due to gravity. Saul's mass is 72.6 kilograms, and acceleration due to gravity is 9.8 meters per second squared. Now that we know Saul's mass is 72.6 kilograms, we can multiply it by 9.8 meters per second squared to get 711.5 newtons. This is the force that Saul hit the water with when he landed. To figure out the velocity at which Saul hit the water, we can use the amount of time that it took him to hit the water and multiply it by 9.8 meters per second squared to get that velocity. 2.33 seconds was the amount of time it took him, and when multiplied by acceleration due to gravity, you get 22.83 meters per second as the velocity.
This is Ariana's jump. So we are using the equation force equals mass times gravity, and my mass is 63.5 kilograms, and the gravity we're using is 9.8 meters per second squared. So plugging in our known values into the equation, we do 63.5 kilograms times 9.8 meters per second, and my force equals 622.3 newtons. So we're going to calculate my velocity at constant acceleration. The equation we're using is v equals acceleration times time. Our known acceleration is 9.8 meters per second, and the time I took to jump off the cliff was 1.53 seconds. So we plug my known values into the equation, 9.8 meters per second squared times 1.53 seconds, and my velocity is 14.994 meters per second when I hit the water.
So this is Ashley's jump. To find force, you multiply mass times gravity. Ashley's mass was a total of 52.16 kilograms, and the gravity was 9.8 meters per second squared. So now plugging in our known values into our force equation, you multiply 52.16 kilograms times 9.8 meters per second, and you get a total of 511.17 newtons. This is now calculating velocity at a constant acceleration, with the equation being velocity equals acceleration times time being the total time it took to jump from the cliff to land in the water. Acceleration was a total of 9.8 meters per second, and the time that it took to jump and land in the water was a total of 1.54 seconds. So once you plug in your values for velocity equals acceleration times time, you get 9.8 meters per second squared times 1.54 seconds to get a total of 15.01 meters per second as your velocity. To determine the height of the cliff, the initial velocity is multiplied by time and added to 1/2 the acceleration times the time squared. Our given data was the initial height to be 0, initial velocity times time to be 0, acceleration 9.8 meters per second squared, and the total time 1.5 seconds. Once we solved for the equation, we received a total of 11.025 meters, which converted is 36 feet